Hello guys, how are you? Welcome back again to our lesson. Today, inshallah, we will have our last lesson in this chapter 13, colligative properties of solution. So far we have learned about the colligative properties for solutions that contain non-electrolytes. Today we're going to discuss about colligative properties for the solutions that contain electrolytes. So electrolytes depress the freezing point and elevate the boiling point of a solvent more than expected. Why? Because electrolytes produce more than 1 mole of solid particles for each mole of compound dissolved. So here, for example, we have saccharose, which is a kind of non-electrolyte, and we have NaC, which is a common electrolyte. And as we can see here, for each 1 mole NaCl, it will dissociate and give us 1 mole positively charged sodium ion and 1 mole negatively charged chlorine ion. So for each 1 mole of sodium chloride, we will have 2 moles of ions, while for the saccharose, which is non-electrolyte, 1 mole of saccharose will yield 1 mole of saccharose after being dissolved in water. So colligative properties depend on total concentration of solid particles, as we said, and it doesn't depend on the identity of the solid particles. The changes in colligative properties caused by electrolytes will be proportional to the total molarity of all dissolved particles, not to formula units as we described it before. For the same molar concentration of saccharose and sodium chloride, you would expect the effect on colligative properties to be twice as large of sodium chloride as for saccharose, because as we said, 1 mole of saccharose will yield 1 mole again of saccharose, while 1 mole of sodium chloride will yield more than 1 mole of sodium. In this case, it will yield 2 moles of ions. So now let us guys see how we can do our calculation for the solution that contains electrolyte solid. Here we have our sample problem F. The question says, what is the expected change in the freezing point of water in a solution of 62.5 gram of barium nitrate? And here we have the formula of this compound in 1 kilogram of water. So given value that we have, solid mass and formula. Solid mass again is 62.5 gram of barium nitrate, and we also have the solid mass and its identity. We have 1 kilogram of water. The formula that we use is delta TF equal to KF multiplied by M, and M represent what, guys? Yes, the molarity, and KF is a constant value that you will find it from the table in your book. So here, to calculate delta TF, we need only to calculate the molarity, and we know that molarity is equal to what, guys? Yes, it's equal to the number of moles of solid over the mass of solvent in kilogram. But here, as we have the mass of the solid in gram, first we need to convert the grams into moles using this formula: mass of solid in grams over mass of solid kilogram multiplied by 1 mole solid over molar mass of solid. The molar mass, you will find it from the periodic table, and it will be equal to the following value. So to convert the amount of barium nitrate from grams to moles, you need to find out the molar mass of this formula from the periodic table, which is equal to 261.35 grams, and then we will divide the grams, which is 62.5, by this value, and we will get 0.239 mole of barium nitrate. So this is the amount of the number of moles of barium nitrate that we will use in our calculation, and we already have the amount of solvent in kilograms, so there's no need to convert to make any conversion for the amount of solvent. So now, as we have the number of moles and we have of the number of moles of the solute and the amount of solvent kilogram, we can find out the molarity. After we find out the molarity, we can easily plot all the values in our formula. Again, the formula was Kf equal to, or delta Tf equal to Kf multiplied by m, and we will find out the final result. But here the exception or the difference is that we need to use the following balanced equation. As we said here, this solution contains what? The solution contains electrolytes. So we need to say for each one barium nitrate, how many ions will be formed. For one barium nitrate, we will get 1 mole barium and 2 moles of nitrate. So the net or the total ions that we will get is equal to 3. Again, according to this balanced chemical equation, 1 barium nitrate will yield 3 moles of ions. So the final answer that we will get should be multiplied by 3, guys, and here we will have our final answer, which is equal to negative 1.33 Celsius degree. So to see if we understood how we do our calculation for a solution that contain electrolytes, let's try to answer this question. What is the expected freezing point temperature for a solution that contains 2 mole of magnesium sulfate dissolved in 1 kilogram of water? So this is much easier than the previous question. We have 2 mole of magnesium sulfate, so we don't need to make any conversion from grams to moles. You need just to find out the chemical formula for magnesium sulfate, and we need to make our equation to see for each one magnesium sulfate how many ions of magnesium and sulfate we will get. If we get 2, the final answer should be multiplied by 2. If we get 3, the final answer should be multiplied by 3. So that's all for today, guys. I expect you to send the answer to my email, and if you have any questions, you can send them as well. Thank you very much. See you tomorrow.